Good day everyone, I am Earl, a representative from Group 6, and we are delighted to present to you different sample problems from different types of circuit, which is the series and parallel, series parallel, lastly is the parallel series. So let's proceed with the first type, which is the series circuit. So for the definition of this series circuit, this involves connecting the loads in a line or series, allowing the current to flow from one load to the next in a single path. So sa madaling salita, ang mga kagamitan ay konektado ng sunod-sunod, ibig sabihin ang daloy ng kuryente ay dumadaan sa bawat isa't isa. So bawat part ng isang series circuit ay mahalaga since hindi pwedeng magkaroon ng problema o hindi pwedeng magkaroon ng sira ang isang parte since makaka-apekto ito sa buong circuit. At ang worst is hindi nagagana yung buong flow ng circuit. So, to give you more example or to give you the sample problem with this series circuit, I will passing the stage to Laika, and here we go.
Let's begin by looking at how a simple circuit allows a light bulb to light. A circuit is a route through which electrical current can flow. In our example, electrons flow from the negative side of a D-cell battery to a conducting material on the base of the bulb. From there, the electrons flow up a wire that is inside the bulb and across the filament, which is the part of the bulb that actually lights. When the electrons go through the filament, some of the electrical energy is changed to heat and light energy. The electrons continue down another small wire inside the bulb to another conductor on the base of the bulb. The electrons finally make their way to the positive side of the battery. There would not be a complete circuit if the electrons did not travel to the positive side of the battery, and the bulb would not light. When there is an unbroken path on which electrons flow, as in this example, it is called a complete circuit. The unbroken path that the electrons follow is called a closed circuit, because electricity will only flow on an unbroken path. The light bulb will not light unless there is a closed circuit. Now look closely at the light bulb, and you'll notice that there is an insulator between the conductor that leads up to the filament and the conductor that leads away from the filament. Remember that the atoms of conductors easily accept and pass on electrons. The atoms of insulators do not. As we discussed in the first section of the lesson, electrons will not easily pass through insulating material that surrounds a wire. If an insulator did not surround a wire carrying a current, it is possible for the electron flow to get directed to another conductor that comes into contact with the circuit. Electricity will follow the path of least resistance. If the electrons take a path short of the complete circuit, it is called a short circuit.
Example number 1. In a series circuit, a 12 voltage battery is connected to a resistor of 4 ohms. Calculate the current and the power flowing through the circuit. So, ang given is, meron daw siyang 12 voltage na battery, tapos nakakonect sa resistor na merong 4 ohms. And the solution is, we will be using the Ohm's law. So, for the current, we have the formula, current equals voltage over resistance. And the current equals to 12 voltage over 4 ohms. So we will be having the result of current equals 3 amperes. And to calculate the power, so meron tayong formula na power equals current multiplied by voltage. So it will be 3 amperes multiplied to 12 voltage. Power will be 36 watts.
Hi everyone. for the example number 2 and problem number 2 for the parallel circuit, number 2 is assume that the current through a resistor of a parallel circuit is known to be 4.5 ampere. And the value of resistor is 30 ohms. Determine the source voltage. The circuit is shown in the figure below. As you can see in the picture below, we have 30 ohms and 4.5 ampere. All we gonna need to find is voltage and yung kung gaano kalakas yung binabato ng voltahe, yung watts. Okay, moving on. Let's go to the solution of this problem. In the given solution, we have 30 ohms and 4.5 ampere. All we're gonna do is to find the voltage of the problem. What formula we will use to find the voltage? All we're gonna do is multiply ampere and volt, ampere and ohms. Okay, all we're gonna do is to multiply ampere and ohms to get the voltage. Okay, what is our ampere? Our ampere is 4.5 and our ohms is 30 ohms. All we're gonna do is times the number. And sorry for the wrong sign. Times po talaga yan, hindi po yan addition. Okay, moving on. 4.5 ampere times 30 ohms. Our voltage is equal to 135 volts. Okay? If pinag-times mo yung ampere and yung ohms, ang makukuha mong sagot is 135 volts. Okay. Now, we have voltage. What is the formula of power? The formula of power is P is equal to voltage and ampere. Okay? So, meron na tayong voltage, yung 135. Meron na din tayong ampere. So, kompleto na. All we're gonna need to do is substitute the number and get the power. Okay. Now, what is ampere again? Our ampere again is 4.5 ampere. And our volts is 135. Multiply it and you will get 607.5 watts. That is our power in this problem. Okay? Meron ka ng power, meron ka ng voltage, meron ka ng ohms, meron ka ng ampere. So, nakuha na natin yung hinahanap sa problem na to. And, nakuha na rin natin kung gaano kalakas yung watts na binabato sa problem na to. That's all, and thank you. Series and parallel circuit. A combination of series and parallel circuit. In this circuit, some of elements are connected in series fashion and some are in parallel. For you to understand more, we will give some problem solving for this one, some example, and our group mates will discuss the problem and their solution.
This is our problem in series parallel circuit. In the circuit below, find the value of unknown resistance or also determine the total resistance of the circuit and total power of dissipated. It's given that voltmeter show a reading of 10 volts. Now, the solution is, first, write the given. The given is 600 ohms, 24 volts, and 100 ohms. The required for this solution is resistance total, and total power. Now, the resistance of parallel combination. Resistance parallel is equal to 600 times 100 over 600 plus 100. The answer is 85.71 ohms. Now, in the circuit current, the formula that we use is Ohm's law. Ohm's law is current is equal to 10 over 85.71. The answer for circuit current is 0.1167 ampere. The voltage across R is equal to 24 minus 10. The answer is 14 volts.
For the value of R, which we need the value of the voltage across R, which is 14 volts, and the circuit current, which is 0.1167. Now, we divide 14 divided by 0.1167, which we get 119.96 ohms. Now, to solve for the total resistance of the circuit, we will need the value of the resistance of parallel combination, which is 85.71 ohms, plus the voltage across R, which is 14 volts. Which we substitute 119.96 plus 85.71, which we will have total resistance of the circuit is 205.67 ohms. Now, to get the total power dissipated in the circuit, we will need the circuit current, which is 0.1167, and the total resistance of the circuit, which is 205.67 ohms. The value of the circuit current will be squared times to the value of the total resistance of the circuit, which is 205.67, which we will have 2.8 watts.
For the last part of the video, we'll be discussing the parallel series circuit. Knowing that the series parallel circuit is basically a combination of a series and a parallel circuit. This type of circuit is a type of combination which, when simplified, the resulting circuit shows a simple parallel circuit. To give you an example, in the problem shown in here, it states that two resistors of 5 and 10 ohm resistance are connected in parallel across a 12 volts battery with 0.2 internal resistance. What power is drawn by the two resistors. The diagram shown on the right shows the characteristics of the two resistors being parallel to each other. When solved together, it then forms a series connection to the internal resistor. Then for the solution, first, we must find the total resistance that are parallel to each other. With the formula for a parallel combination presented earlier in the slides, we now substitute 5 ohms and 10 ohms. The total resistance when computed would be 3.33 ohms. Next, we'll compute for the total resistance with the internal resistance from the then formed series circuit. With the formula of a series circuit, we now add the total resistance from the parallel combination, which is 3.33 ohms, to the 0.2 internal resistance. Then the new total resistance now would be 3.53 ohms. To find the power drawn from the two resistors, we must first find the current. The formula for the finding of the circuit current is I equals to the energy, or the volts, over the resistance. Therefore, substituting the 12 volts from the given and the 3.53 ohms resistance, we now get the value of 3.4 amperes as the current. And lastly, to compute for the total power dissipated in the circuit, the formula would be P equals to the current squared times the total resistance. Therefore, P is equals to 3.4 squared times 3.33. The final answer would be 38.5 watts as the power drawn in the circuit. Now that we talk about that parallel series circuit, We then have learned all about the different types of series and parallel circuits. From the series circuit, parallel circuit, series parallel circuit, and the parallel series circuit. And then we've given some examples to learn about them. That concludes our topic about the series and parallel circuits. That's all. Thank you.